Welcome students, we have a beautiful question. Given that x raised to the power of x raised to the power of 5, if it is equal to 5, then we are expected to find the value of x. So foremost, what I wish to do is I would like to take x raised to the power of 5 to be equal to some a. Then I would like to apply fifth root on both sides. Now if I were to do that, this is going to be x raised to the power of 5 raised to the power of 1 over 5, and this is equal to a raised to the power of 1 over 5. Now clearly, as I mentioned to you, if you have a quantity like this, a raised to the power of m, the entire quantity is raised to the power of 1 over n, then this is going to be a raised to the power of m over n. So by that fact, what happens, this 5 and this 5 can be cancelled, giving me x is equal to a raised to the power of 1 over 5, or it's going to be fifth root of a. So what I wish to do is I would like to utilize this into the original system. So if I were to take this as 1, therefore 1 can be rewritten as, in place of x, this is what we've got, right? X raised to the power of x raised to the power of 5 is equal to 5. This is what we have got. So as I mentioned to you, I will be utilizing this fact over here. So this is going to be, in place of x, I'm going to substitute fifth root of a. In place of this x, it's going to be fifth root of a, and this has got a degree 5 there as an exponent. So you have to place that, and this is equal to 5. So this is what you've got. So now what I wish to do is I would like to perform some manipulations so that we were in a better position to equate the bases and the exponents. That's exactly what I'm going to do. So this is actually, let me write that down, fifth root of a, this is raised to the power of 5. As I mentioned to you, fifth root of a is nothing but a raised to the power of 1 over 5. This is raised to the power of 5. Clearly, by the law of indices, 5 can be cancelled, giving me a. So that is the simplification for the index that you see here. So this is going to be fifth root of a, the whole is raised to the power of a, and that is equal to 5. Now what I wish to do is I would like to raise both sides to the power of 5, or to the value of 5. So let me do that. So this is raised to the power of 5. This is raised to the power of 5. Right? Now, this quantity which you see here is actually a raised to the power of 1 over 5. Right? And that is raised to the power of a, and which in turn is raised to the power of 5, which is equal to 5 raised to the power of 5. Now, a raised to the power of m, all raised to the power of n, is rewritten, can be rewritten by the law of indices as a raised to the power of n raised to the power of m. Right? Now, in place of m, suppose you have a raised to the power of 1 over m, like this entire quantity being raised to the power of n, then what I can do, I can also flip them, a raised to the power of n, the whole raised to the power of 1 over m, or I can rewrite this as a raised to the power of n over m. So all of these things are possible from the law of indices. Okay? So what exactly I wish to do is I would like to move this 5 inside. So if I were to move that 5 inside, I would have a raised to the power of 1 over 5 times 5, the entire quantity being raised to the power of 8. So I'm just moving this 5 inside, like the way I moved this n inside. Alright, so this is equal to 5 raised to the power of 5. Now clearly 5 and 5 can be cancelled, and I would have a raised to the power of a is equal to 5 raised to the power of 5. Now clearly the bases can be equated, the indexes can be equated, giving me the value of a to be equal to 5. But this is not the final solution. Why? Clearly you can see the x value has to be found out, right? And x is equal to fifth root of a. So therefore x is equal to fifth root of, and what did we have for a? A is nothing but 5. So this is the final solution, or you can rewrite this as x is equal to 5 raised to the power of 1 over 5. So that is the good place for us to stop